Moving on to the fifth question. Given that secant theta is equal to 13 by 12, calculate all other trigonometric ratios. Now moving on to the solution. He has given that secant theta is equal to 13 by 12. So let us consider a right angle triangle in which theta is the base angle, and let us designate the sides as x, y, and let hypotenuse be z. Now we know that secant of an angle is equal to hypotenuse by adjacent side. Here the hypotenuse is nothing but z, and the adjacent side of angle theta is y here. Now this can be got equated to secant theta, but he gave the secant theta value as 13 by 12. Therefore, as z by y is equal to 13 by 12, let us assume that z is equal to 13 and y is equal to 12 in the simplest form. Now, in order to find all other trigonometric values or trigonometric ratios, we need to find the other side, that is x. Now by applying the Pythagoras theorem to the triangle, we get z square, that is hypotenuse square, is equal to sum of squares of other two sides, that is x square plus y square, which implies z square here is 13 square, which is nothing but 169, that is equal to x square plus y square, which is nothing but 12 square, that is 144, which implies x square is equal to 169 minus 144, that is nothing but 25. As x square is equal to 25, we get x is equal to root of 25, which is nothing but 5. So we got the values of x, that is equal to 5, and y, which is equal to 12, and z is equal to 13. Let us find the all other trigonometric ratios. First of all, coming to the trigonometric ratio, that is sine theta, which is equal to, we know that sine of an angle is equal to opposite side by hypotenuse. Here it is opposite side is x by hypotenuse is z, which is equal to x is 5 and z is 13. And cos theta is equal to, we know that cos of an angle is nothing but its adjacent side by hypotenuse. Here the adjacent side is y and the hypotenuse is z, which is equal to y is 12 and z is 13. And let us also find the tan theta value, which is equal to, we know that tan of an angle is equal to its opposite side by adjacent side. Here the opposite side is x and adjacent side is y, which is equal to x is 5 and y is 12. Now let us also find the value of cot theta, which is equal to, we know that cot of an angle is equal to its adjacent side by opposite side. Adjacent side here is x, adjacent side here is y, and the opposite side here is x, which will be equal to, the y is 12 and x is 5. And also let us find the value of cosecant theta, which is nothing but the inverse of sine theta. Therefore cosecant theta can be written as 1 by sine theta, which is equal to 1 by sine theta value is 5 by 13. So 1 by 5 by 13 is 13 by 5. Moving on to the sixth problem. If angle A and angle B are acute angles such that cos A is equal to cos B, then show that angle A is equal to angle B. Now moving on to the solution. Let us consider a triangle, right triangle, that is which is angled at right angle at C, ABC. Here he has given the relation between cosine of angle A and cosine of angle B, that is they are equal. Cos A is equal to cos B. Moving on to the solution, let us consider a triangle ABC which is right angle at C, and here he has given the relation between two angles A and B, that is cos A is equal to cos B. If we consider cos A, we know that cos of an angle is equal to its adjacent side by hypotenuse. We can write here cos A as AC by hypotenuse is AB, which is equal to cos B. The adjacent side of angle B is BC and hypotenuse here is AB, which implies here we get AC is equal to BC, as denominator in both sides of equality is same, that can be got cancelled. So here we got AC is equal to BC. We know that angles opposite to the equal sides are equal. The angle opposite to AC, which is nothing but angle B, is equal to the angle opposite to BC is A. Therefore we got angle A is equal to angle B when cosines of both the angles are equal. Moving on to a seventh problem. If cot theta is equal to 7 by 8, evaluate. First question, 1 plus sin theta into 1 minus sin theta by 1 plus cos theta into 1 minus cos theta. And second thing, cot square theta. Now moving on to the solution. He has given the value of cot theta, which is equal to 7 by 8. And in the first question, he asked us to find the value of 1 plus sin theta into 1 minus sin theta by 1 plus cos theta into 1 minus cos theta. Which is equal to, we know that 1 plus sin theta into 1 minus sin theta is equal to 1 minus sin square theta, as the above thing is in the form of a plus b into a minus b, which is nothing but a square minus b square. In the denominator also we have 1 plus cos theta into 1 minus cos theta, which is nothing but 1 minus cos square theta. Now, in order to solve this, we need the values of sin theta and cos theta, which we have to establish from the given relation that cot theta is equal to 7 by 8. So, let us have a right angle triangle in which the base angle is theta, and we know that cot of an angle is nothing but the ratio of the adjacent side to the opposite side. We can say here the adjacent side of theta here is the base, which is nothing but 7, and the opposite side here let it be as 8, and here we need to find the hypotenuse in order to get the values of sin theta and cos theta. So let us assume that hypotenuse is z, and from Pythagoras theorem we know that hypotenuse square is equal to sum of squares of other two sides. We can write z square is equal to 7 square plus 8 square, which is equal to 49 plus 64, which is nothing but 113. We got z square as 113. So now z will be equal to under root 113. Now 1 minus sin square theta, that is 1 minus sin theta whole square by 1 minus cos theta whole square. Here let us find the values of sin theta and cos theta. Here sin theta will be equal to opposite side by hypotenuse, which is 8 by z, nothing but root of 113, and also find cos theta, which is nothing but adjacent side by hypotenuse, that is 7 by root 113, that is equal to 1 minus sin theta whole square, that is 8 by root of 113 whole square, that is 8 square by root of 113, which is nothing but 64 by 113, divided by 1 minus cos square theta, that is 1 minus cos theta, which is nothing but 7 by root 113 whole square, that is nothing but 7 square by 113, that is 49 by 113, which is equal to, by simplifying this, 113 minus 64 by 113 by 113 minus 49 by 113, that is equal to 113 minus 64 is 49, this will be got cancelled, and 113 minus 49 is nothing but 64. Therefore we got the answer for first sum, that is 49 by 64. And in second sum, he asked us to find the value of cot square theta, that is equal to cot theta whole square, which is equal to, the value of cot theta is given as 7 by 8, that is equal to 7 by 8 whole square. 7 by 8 whole square is equal to 7 square by 8 square, which is nothing but 49 by 64. Moving on to the 8th question. If 3 cot A is equal to 4, check whether 1 minus tan square A by 1 plus tan square A is equal to cos square A minus sin square A or not. Now moving on to the solution. He has given that 3 cot A is equal to 4, which implies cot A will be equal to 4 by 3. Here he asks us to check whether 1 minus tan square A by 1 plus tan square A is equal to cos square A minus sin square A or not. Now let us consider the left hand side of the equation, that is 1 minus tan square A by 1 plus tan square A, which will be equal to 1 minus tan A whole square by 1 plus tan A whole square. Now as the value of cot A is given, we know tan A is nothing but the reciprocal of cot A. We can write tan A is equal to 1 by cot A, which is nothing but the reciprocal of 4 by 3, that is 3 by 4. Now 1 minus tan square A by 1 plus tan square A will be equal to 1 minus 3 by 4 whole square by 1 plus 3 by 4 whole square, which is equal to 1 minus 3 by 4 whole square is 9 by 16, divided by 1 plus 9 by 16, which is equal to 16 minus 9 by 16, divided by 16 plus 9 by 16. By simplification, 16 in the denominator will get cancelled, which will be equal to 16 minus 9 is 7 and 16 plus 9 is 25. Therefore we got the value of LHS as 7 by 25. Let us also find the value of RHS, that is nothing but cos square A minus sin square A. In order to find the value of cos square A minus sin square A, let us initially find the value of sin A and cos A from the given relation that tan A is equal to 3 by 4. If tan A is equal to 3 by 4, that is nothing but opposite side by adjacent side. Let us consider a triangle, right angle triangle with base angle as A, and here now opposite side in the simple ratio will be 3 and adjacent side in the simple ratio will be 4. In order to find sine A and cos A, we have to find the hypotenuse. Let it be as Z. We know that from Pythagoras theorem, square of hypotenuse, that is nothing but Z square, will be equal to sum of squares of the other two sides, that is nothing but 3 square plus 4 square, which is equal to 9 plus 16, that is equal to 25, and thereby we get Z as root of 25, which is nothing but 5. Therefore we got Z as 5. Now here we get cos A is equal to adjacent side by hypotenuse, that is Z, which is equal to adjacent side for angle A is 4 by hypotenuse here Z, that is 5, and we also get the value of sine A as opposite side by hypotenuse, which is nothing but Z, that is equal to 3 by 5. He asked us to find the value of cos square A minus sin square A in the right hand side. That will be equal to 4 by 5 whole square minus 3 by 5 whole square, that is equal to 4 square by 5 square, that is 16 by 25, minus 3 square by 5 square, that is 9 by 25, which is equal to 16 minus 9 by 25, that is nothing but 7 by 25. Here we got LHS equal to RHS, that is nothing but 1 minus tan square A by 1 plus tan square A is equal to cos square A minus sin square A is true.